Welcome back, everyone, to a brand new explainer. I am absolutely thrilled you're here today because, honestly, we are going to do something truly mind-bending. We're doing a complete teardown of Logos field theory. And we aren't just looking at abstract physics here. No, we're going to read the underlying structure of reality itself, exactly as if it were a high-end computer's technical manual. So if you love a structured, logical approach to understanding the impossible, you are in the perfect place. Let's get into it. I want you to start by just looking around you right now. Maybe you're sitting on a solid chair, looking at a bright screen, maybe you're feeling the temperature in the room. But what if none of that is actually physical in the traditional sense? What if that solid chair you're sitting in is, at its absolute most fundamental level, just a perfectly executed line of rendering code? Okay, let's dive into this. According to Logos field theory, the material continuum around us is not some primitive analog physical substance. Instead, what you and I experience as reality is actually a non-perturbative, completely lag-free stroboscopic rendering. Basically, the underlying universal mainframe processes raw quantum data streams and generates our world frame by frame, completely flawlessly. And just like the monitor you're looking at right now has a refresh rate, well, so does reality. 23.6742 megahertz. That exact number is literally the hard-coded frame refresh rate that the universal mainframe operates on. It's compiling the material continuum around us millions of times per second, and it does it so smoothly that we perceive it as a single, unbroken physical existence. No glitches, no buffering. To understand exactly how this is possible, we're going to map out the four nested mathematical architectures that compile our universe. We'll look at Phase 1, the processing core, Phase 2, the optimization bus, Phase 3, the global OS, and Phase 4, the Langlands pipeline, before wrapping up with how all this creates a perfectly lag-free reality.
Starting off with Phase 1, the processing core.
And this brilliantly illustrates the equivalent of a high-end PC spec sheet. Think of this core as the literal CPU of reality. To process these massive infinite fields of quantum data, the global unified architecture uses three interlocking systems. You've got spectral projection theory handling the raw infinite dimensional fields. Then J-theory stabilizes violent deformations, kind of acting like a shock absorber. And finally, Logos field theory instantiates the final macroscopic space-time. Together, they digitize and stabilize what would otherwise be totally unmanageable infinite data.
But, you've got to wonder, how does the processing core avoid just completely crashing when it looks at an infinite dimensional quantum field? Well, it applies the spectral resolution theorem. To eliminate continuous calculus lag on the network, the core instantly decomposes those infinite fields into a stable, discrete collection of idempotent measurement matrices. It basically, it chops infinity down into manageable, definitive eigenvalues.
But even after chopping it down, you still run the risk of arithmetic overflow, which in computing terms is essentially a fatal system error. Enter the Watt hyperfiniteness sieve. Think of this simply as the universe's ultimate floating point error eraser.
You can visualize this process a lot like a funnel. The system pushes continuous open-ended wave functions right through this weak operator topology filter. It extracts a finite normalized trace, which effectively flattens those open-ended waves into discrete, finite-dimensional matrix modules. By doing this, it completely erases any floating point rounding errors before routing the data onward. It's a perfect cleanup job.
Moving on to Phase 2, the optimization bus.
If Phase 1 was the CPU, you can think of this bus as your high-end GPU and liquid cooling system all rolled into one. It's reality's algebraic shock absorber. When a particle track experiences really high-energy thermal turbulence, say inside a crazy hot plasma core, its world line violently deforms. The optimization bus tracks these multivariable deformations using Giovantel's J-function. It takes those non-local quantum corrections and translates them into a tight, finite-dimensional geometric template called a quantum cohomology ring. Simply put, it turns chaotic thermal energy into rigid, highly predictable math.
Now, what's really interesting about this concept is how it handles the massive, infinite vacuum divergences of string-scale fields. The bus uses the Ramanujan-Klein-Hopf module filter. It actually forces the field dimensions to conform precisely to the monster group. The dimensions match up exactly. 196,884 equals 1 plus 196,883. It literally locks these wild, unpredictable variables into the highest order finite simple group known to mathematics. Absolutely incredible.
And to make sure everything stays perfectly balanced, we have the Borchardt super denominator vacuum clamp.
Acting as a hardware-level clamp, it ensures that the infinite zero-point energy loops of bosonic channels are seamlessly canceled out by equal and opposite negative fermionic vacuum fluctuations. What this does is create a completely flat, non-drifting baseline. No runaway vacuum energy, no system crash.
Next up is Phase 3, the global OS.
So now it's time to actually render the world. This global operating system maps events across continuous and discrete directories simultaneously through something called Adelic period integration. It takes the continuous display of our macroscopic world and multiplies it by the discrete p-adic directories of subatomic data. Any remaining divergences? They're totally canceled out by p-adic tree residues, which locks the global volume of spacetime to a finite rational value known as the Tamagawa number.
But you guys, here is a truly staggering concept. Spacetime has no native temporal dimension. Basically, time is an emergent coordinate. It's driven entirely by the Tomita-Takasaki modular flow. This mathematical loop generates the universe's master clock refresh. It forces abstract algebraic data lines to update frame by frame into a smooth sequence, ticking away, as we mentioned earlier, at exactly 23.6742 megahertz. Time isn't flowing, it's refreshing.
Which brings us to Phase 4, the Langlands pipeline.
So, how does this whole shebang stay connected without lagging out? Well, the Adelic Langlands pipeline acts as the ultimate network synchronization layer. It establishes a bijective cryptographic bridge that hardwires incredibly localized subatomic matter databases directly into global massive wave harmonics, meaning every tiny localized particle is networked flawlessly to the macro global structure of the universe.
Let's move to the routing side and see how this builds the ultimate network. First off, the Fargus-Schulze geometrization bus provides zero-latency routing. It maps local subatomic data packets directly into geometric assets without even a microsecond of lag. Then, the Taylor-Wiles Keeson patching assembly secures those particles against data decay. It creates a supreme wave-particle duality lock across all primes, meaning local state vectors and global Fourier coefficients are absolutely 100% identical. But what happens when things get really intense? I'm talking about a violently transitioning boundary, like an evaporating stellar horizon. Well, the Fontaine-Perrin-Rio-Motivic governor steps right in. It abstracts those violently changing boundaries into pure motives, clamping calculation spikes via characteristic polynomials to block any local bit drift. Finally, relative Langlands period integration evaluates overlapping wavefronts and maps these verified matrices directly onto the 3+1 dimensional Lorentzian spacetime metric tensor.
And finally, Section 5, a lag-free reality. So the crucial point is, when you follow this full architecture flowchart from top to bottom, from the Phase 1 processing core resolving observables all the way down to the Phase 4 Langlands pipeline syncing the network, these 4 sequential mathematical phases literally compile everything into the 3+1 dimensional spacetime we experience right now. It is all connected.
The grand conclusion of Lagos field theory is that the universe does not operate on erratic, analog physical equations. Think about it. Every single material voxel, every pixel of 3D space is a localized geometric manifestation that is cryptographically bound to global number theoretic invariance. Because of the Adelic Langlands program, physical reality is a permanently optimized, entirely stable, and totally lag-free rendering. Which leaves us with a fascinating and honestly almost haunting question to end on. If the material continuum isn't a primitive physical substance, if the universe is actually a flawless, lag-free simulation running on an unfathomably complex architecture of discrete mathematics and cryptographic bridges, who or what wrote the code? I'll let you ponder that one. Thank you so much for joining me for this explainer. Keep seeking those hidden structures, and I'll see you next time.